All right, welcome back to Ad Seriatim. If you're new here, feel free to like, comment, and subscribe. Last video, we went over the college scorecard dataset. Now, this dataset has financial information about all the institutions in the U.S. lower 48, as well as the outlying regions. During that video, we went over some about the data, what's in there, as well as we did our first shot at trying to impute some of the missing values because that data is really messy. Now, we did an okay job, but we came with some pitfalls. The first one being that we tried to use the median from each zip code. That didn't quite work. We saw that some zip codes were a little too small to be able to take the median. Some had one or no schools in that zip code. So we're going to try a different approach. In this video, we're going to do two things. The first thing being is we're going to try iterative imputer by scikit-learn. If you're not familiar with iterative imputer, feel free to look at the documentation. It's very nice. Essentially what it does is it creates a regression equation to try and predict those missing values based on the rest of your data set. So we're going to use that, but I'm a little wary. So what we're going to do, we're going to have a little bit of a twist. We're going to use it, but we're going to evaluate it first, similar to a supervised learning problem. And then we're going to see if we want to go with it or not. The second thing we're going to do is once we have imputed our data and cleaned it up, we're going to create a Streamlit dashboard to be able to present these metrics and query it for any students who might be looking for an institution in-state, out-of-state to see what might be in their budget. Let's get started. The first thing we're going to do is import our libraries, pandas, matplotlib, seaborn, and numpy. Next, we're going to read in our CSV file. And these are going to be our columns for analysis. Now I already have it written out here. We have the institution ID, the institution name, city, state, zip code, the predominantly awarded degree, the highest awarded degree at that institution, the control, the region, the cost per program year or academic year, the in-state tuition, out-of-state tuition, the tuition per full-time equivalent, the instructional expenditure per full-time equivalent, the average faculty salary, and then the locale. The locale is essentially what kind of region or district is this university in. And so we just run that. Let's check the head. Next thing we're going to do is look at all the nulls. And so we see we have some nulls in the cost for attendance. Similar to the last video, this isn't anything new. And let's get the proportion of those nulls in this data set. We still have 50%, 42%, so we have some nulls. And again, we're going to try this iterative imputer method to try and impute these methods, but we're going to evaluate it first. Let's clean it a little more. Let's only look at institutions that offer an AA or higher, so an associate's degree, bachelor's degree, or master's, or a higher education degree. And let's double check to see if they're in there. There we go. So we have only associates, bachelor's, and then upper education, or I guess advanced degree. Now the first thing we're going to do is grab the finance data. So we subsetted it, but we don't want to impute based on the locale or region. We just want to use this finance data to see if we can do a good enough job of seeing what the actual data should be. So let's actually only grab that finance data. Okay, let's run this. Perfect. Now, we're going to impute values using iterative imputer. Again, if you're not familiar with iterative imputer, go to the scikit-learn documentation. It explains it very well. Essentially, the algorithm we're going to use is we're going to remove all the null values from our data set. So we have a data set that has some null values in there. We want to essentially use this as our validation set. So we're going to remove all those null values so we only have a data set that has no null values. Next, we're going to create random null values proportional to the full data set. So the full data set, like we saw earlier, some of those columns had 50% nulls, 20% nulls, or 30% nulls. We're going to get that proportion of nulls, and then we're going to impute random null values that is proportional to what's actually null in that column. The next thing we're going to do is we're going to test imputation with mean absolute error. So these are going to be some of our error metrics: mean squared error, root mean squared error. And then we'll generate some visualizations such as a box plot, a histogram, and a scatter plot just to get an idea of what we're seeing. And then we'll actually see if we're going to use it or not. So when you're doing something like this, it's important before you begin your analysis to have some kind of actual ground truth or some kind of threshold. What are you okay with? What kind of variation are you okay with? How do you know if your model is performing okay? You don't want to actually test your model and then retroactively kind of decide if it's good enough or not. You want to have a value in mind beforehand. So what we're going to do is we'll use the iterative imputer if the mean absolute error is less than $10,000. That gives plus or minus $20,000. I think that's a very generous wiggle room. If the iterative imputer does not do better than this metric, we're not going to use it. So we're going to import our libraries from sklearn. We have to import the iterative imputer as well as mean absolute error and mean squared error. So the next thing we're going to do is we're actually going to copy that data set. There we go. Now we're going to get the column names, so the column names to compute. So this is going to give us our column names that we can then iterate over. Now we're going to get the proportion of nulls. So like I mentioned, our full data set has a certain proportion of nulls in each one of those columns. We want to mimic that in our test data set so we have something that's apples to apples comparison. And so to do that, we're going to get this proportion. So first, let's comment this up. Nulls equals and so we have that first unit ID that we copied over. We really don't need that, and so we're gonna slice it and remove that column because that column has no nulls, and we don't want to use it. We don't want to have the iterative imputer think that's the value that we want to use in that regression equation. We just want the financials. And so the next thing we're gonna do is actually get the proportion. And we're going to round it to 2 numbers. And then we're going to cast it to a list. Okay, so let's walk through this for a moment. We have our get proportion of nulls. The first thing we do is get all the nulls in that data set. So we find all the nulls, all rows that have nulls. Next, we're going to, or get the count for each column that has a null. The second thing we're going to do is of that number, we're going to get the proportion. So we're going to get the length of the full data set, and then we're going to round that to 3 numbers. And then we're going to cast that to a list. The next thing we're going to do is convert that list to a dictionary that has the column as well as the proportion right next to it, so we can use that really easily. We're going to use list comprehension, or excuse me, we're going to zip the 2 lists together. And let's run that. Sorry, one thing, we need to get the index. My mistake, we have to get the index. There we go. Now, next. Now we're going to impute the null values using the iterative imputer. So those randomly assigned null values, we're going to impute them. But the thing is, we know what the actual value is for those actual null values. And so we can actually generate some error metrics because we know what the ground truth actually is for that value. And so first, let's call that iterative imputer. Random state equals 0 for reproducible results. And then for max iterations, let's do 20. The default is 10, but let's do 20. Let's impute the values. Fit transform, let's pass in that data set. And then let's cast that to a data frame. The columns are the actual columns to compute. And let's take a look at the head. All right, so now we have our imputed values. We have the cost of attendance, tuition fee in state, tuition fee out of state, tuition per full-time expenditure, instructional expenditure per full-time equivalent, and the average faculty salary. So these values, which is 1.0, were original. These ones with the long float, these ones are imputed values. Now we want to round that so that we get an actual number that's representative of what we're looking at. And so just round that by doing all right, so we rounded those numbers. Now let's actually calculate those error metrics that I was talking about. If you remember one more time, we have our full data set with nulls. We take away those nulls. We have a full complete data set with no nulls. We insert nulls at proportional to the original data set. We impute those nulls and we have the actual value. So essentially we're doing a train, test, split, like a supervised learning problem. So it's actually calculate those error metrics for each one. So the way to do that is a little bit different. We have to actually get those indices that we have to find those indices that we made for null that were in each column. And it's not the same for each column, so we have to actually iterate and find them through each one. So it's going to be a little bit longer, but bear with me for a moment. Let's create a dictionary. Now it's going to a for loop. And we're iterating over those columns that we're going to impute. So cost for attendance, or cost tuition for program year, tuition fee in state, tuition fee out of state, tuition fee for full-time equivalent, and expenditure for full-time equivalent, and average faculty salary. So again, let's get the null column. And let's get those indices that are actually null. That is null. And then let's get the index for the, so now we subset to just the rows that are null, but we just want to get the index. Let's get our imputed data and get those same indices. Okay, .loc, we're indexing it, and we're going to null data index. And the next thing we're getting is the actual column that of those. So we subset it to the rows. Now let's get the column that we're actually iterating over. All right. Next, let's calculate the mean squared error. Mean absolute error. Now again, what this metric is you take the absolute distance between the prediction and the actual value, regardless of if it is overshoots it, undershoots it, positive or negative. It takes the mean or the absolute value of that and the mean of all those values. Mean absolute error. We're taking our true values. Oh, I forgot one more thing. We have to get our true values. So true value df. So what we actually know to be true for that imputed value. And we're getting the same null data index in the true value column of the one that we're actually iterating over. All right. Now we're going to get the mean absolute error, and we get the true value column, and we're getting the imputed data column. The next thing we're going to do is the mean squared error. So this is actually when you take that error and you square it, so it penalizes larger outliers and bad predictions a lot harder than the mean absolute error. Same thing, C equals squared error, true value, and the imputed value. And now we're going to calculate the root mean squared error. We take that mean squared error and you take the square root. So it's less punishing, and the actual unit, or actual in this case, is going to be dollars instead of some other number. Dollar squared, I guess, if that's a thing. Take the np.square root. Very nice. And we put in the MSE, or the mean squared error. Next, let's save these in our actual dictionary so that we can create another data frame to visualize it very easily. Take that call. So remember, the columns are the keys, so we just pass in that column for the key, and we pass in a list of the mean absolute error, mean squared error, and the root mean squared error. So let's run this. Now let's actually create a data frame from this column, and let's view it to make sure everything looks good and just get an idea of what's actually in there and see if this iterative imputer meets our threshold. So what we're going to do is we're going to get that data frame, we're going to get that dictionary. All right. Next, we're going to get make the index the mean absolute error, mean squared error, and mean root mean squared error, so we have a better idea of which one is which. And let's take a look at this error underscore df. All right, so we have our error metrics here. The mean absolute error for the cost of tuition for one program year is $3,000. In-state tuition around $2,000. For out-of-state tuition, $3,000. Tuition per full-time equivalent, $6,000. That seems a little high. And expenditures per full-time equivalent and average faculty salary, $2,000 and $1,000 respectively. I don't think this is very, very bad. Well, one, these meet all of our threshold. Our threshold was $10,000. Now it might have been a little generous, but we're being generous on purpose so that we can actually have something to show everybody. We don't want to actually disclude data that might be valuable in the future. Next, let's make some visualizations. So first, we're going to start with a box plot. Now for some of these, I'm actually going to start copy and pasting a little bit of these code snippets just because I don't want the basis to be making visualizations. I just want to make these so we can look at them, get an intuition of what's happening, and then move on to the next portion of this video. So we're actually going to make a grid for these visualizations, or for these box plots, histograms, and scatter plots. All right, so there's gonna be a lot going on here, but bear with me. So we have fig.ax, we have our matplotlib figure object that we're going to use. We have the number of columns, number of rows for our grid. We're going to flatten the array to actually make more than one row. And now we're going to generate our figures iteratively. We're going to go through each column, compare the null data or the imputed data versus the true value data that we have. And we're going to rename it. We're going to actually make a data frame and rename it. And we're going to create the box plot. Any unused subplots, we're going to remove them. And then we're going to make the layout tighter. So let's run this and see what happens. Now we have our box plots, and we see some of them are skewed. We see the medians are pretty spot on, but this iterative imputer probably used the median or the mean in some fashion to try and impute these values. We see the variance is fairly spot on. We honestly see it's pretty good. We see true values and imputed values for tuition per full-time equivalent is kind of off, as well as it's very off for in expenditures per full-time equivalent. And then for average faculty salary, we see the variance is a little higher. We do have some outliers here, but overall it looks pretty good. Now I'm not sure what's happening here, but our next figures should show us pretty well. Let's look at that histogram. And so again, I'm just gonna start copying and pasting on some of these code snippets I already have, just because I don't want to have this be too long on visualizations. Okay, so we have our subplots, we flatten it. Again, we're iterating over the columns, we're getting the imputed data, the true data, and then we're actually making a data frame and then plotting them against each other. So let's kind of look and see what we see. All right, so let's take a look and see what we have. For the cost of tuition for one academic year, we see the imputed values are in blue and the true values are in orange. So we see it maybe overestimated the mean a little too much with the imputed values on the cost of attendance. In-state tuition, we see it maybe underestimated the actual mean in this one. We see it was a little positively skewed for the tuition of out-of-state. And then there weren't a lot of full-time equivalent data points. So that's part of the reason why we're seeing that such that large variance. Same with the in expenditure for full-time equivalent. For the average faculty salary, we see maybe it underestimated overall. But overall, it looks not bad. Now let's look at maybe one more scatter plots just to get an idea of the agreement between those two measurements. So again, I'm going to copy and paste this code snippet. There we go. We do see a pretty good relationship. Some variance here, some outliers, but overall pretty good. Same with the in-state tuition and the out-of-state tuition. Again, we might see it might have overestimated the values a little bit, but that's all right. Pardon me, it might have underestimated the values a little bit, but that's all right. Again, not a lot of data in these two. Average faculty salary, not bad, but still a lot of variance there. Overall, we're going to use it. It was a pretty good thing to go through, though, just to double check if this is a good method to use in our data. So let's impute the data on the full data set now. So we still have that actual model on our imputation, or to imputation, then we're going to fit and transform. And we're going to pass in, before we do that, we're going to actually cast this to x, a variable x to pass in. Our full data set is the DF cleaned one. And remember, we're only going to get that financial data. And that financial data is from cost for A all the way to average faculty salary. We're going to pass that in. And next we're going to actually round the values again. NP.round, because we're going to have a long end on that imputation. And then we're going to make the final data set. We're going to merge it back to our original data set. But first, let's run it. Oop. Mess that up. Missed one thing. We're going to cast it to a data frame. And the columns are going to be the columns that we actually passed in. Perfect. Now let's see if this works. There we go. Since this is returning it to us, we actually have to save it in our data frame. Perfect. Let's actually merge it back to our original data set, export it, and then let's get ready for the Streamlit application. So first, I'm going to copy this over because I don't want to spend time typing all of this out. Perfect, and let's take ahead, just take a peek at it just to make sure it looks good. Looks pretty good to me. Now we might have some nulls over here in the regional data set. That's all right, I'm not too worried about that. If we want to go back and fix that, that's all gravy. Now let's export this and get ready for the Streamlit application. All right, we're here in our main.py, and now we're going to make the Streamlit application to allow a user to query this data set that we just cleaned, find schools within their price range, and then be able to get some more information about the financials about that state. Now, let's import our libraries. Of course, we're using Streamlit to actually generate the web application, pandas to hold the actual data frame, NumPy for some vectorized operations. Well, we might not actually need NumPy, so let's delete that. Plotly Express. So what you want to do if you haven't is you want to do pip install Plotly Express, just like that. I already have done it, so I already have the requirement satisfied, but you want to download it just so you are able to use Plotly Express. Now, if you haven't used Plotly before, it generates interactive plots on Streamlit. It uses Streamlit or Jupyter Notebook, wherever you want. And it's a lot easier, a lot simpler syntax than the full Plotly package. And so we're going to import it as px. And this should be it. So the first thing we're going to do is load the data, but when we load the data, we're going to cache it because every time we run something, we don't want to have to load it in every single time. So we're going to cache it in memory so it makes a better user experience. And we use this @ decorator for caching the data. And then we're going to define our function to actually load in the data, which is going to be load data, or passing in nothing. And then we're assigning it to a data frame named df, pia.read. And let's get the actual path, which is going to be, let's move this over here. Relative path. Let's put it in there, just like that. And let's return the df to us. And so now we're going to actually load the data. df equals load underscore data. And we're good to go. Now, before we go any further, what we're going to do is actually run our application. Run our application so that whenever we make a change, we can see it live in the browser. And so we're going to move this to the side. And in our terminal, we're going to do run or Streamlit run main.py. Now main.py is the name of my file, but if you've named your file something different, make sure you change main.py. And it should open up. Have a typo here. And I'm going to change it to always rerun. So you can have it to just run or always rerun. I'm going to have it always rerun, so whenever I save it, it's going to automatically update that data frame or that Streamlit. And so the first thing we're going to do is have the title. We need a title for our dashboard. The title of our dashboard is going to be U.S. Colleges Information Dashboard. There we go. And we're going to add a select box to the sidebar. Now the first one is going to have the user select a state from a drop-down menu. And so let's comment add a select box to sidebar. And it's going to be a state. So we're going to stay at the state level for now. Maybe in the future we can add some zip codes or add an actual region or something, but let's just start with a state. st.sidebar.selectBox. And what we're going to do is add in an actual prompt, select a state. And for the state, we're going to do df stabber is the actual column name, and then .unique. Now they all are unique as far as I'm aware, but just in case they're not, just .unique. There we go. We updated it. We see U.S. Colleges Information Dashboard, and we have select a state here on the left, so we can select from our list of states. Now next, what we want to do is be able to filter the data depending on what the user uses. So if, let's say they chose Alabama, now the data frame is filtered to only states from Alabama. And so to do that, we're going to do filtered underscore df equals df, and then we're going to put in stabber, because that's that column name, equal to state. Perfect. Next, we're going to display the selected state's data. So this is going to be actual subheader so the user knows what they're seeing. And so we're going to put an F string, data for state, data for colleges, in state. And the state, F string, passing in that variable. Let's see that reflected. Yep, data for colleges in Alabama. Now we're going to start to display some descriptives and some figures. The first thing we're going to display our 3 cards at the top. Now each card is going to have a different metric. We're going to have the mean cost of that state, the median cost of that state, and the median expenditure for that state. Now the median expenditure is going to be the median expenditure per full-time equivalent. And so what we're going to do is mean cost. We're going to round it because remember we had that long runoff for all those imputed values. Actually, perhaps we don't need to round it. And for this, we're going to use tuition, in-state tuition. Maybe in the future we can have out-of-state tuition as well, but to begin, let's just have in-state tuition, not the cost of a full academic year, not the cost of a full academic year, because the cost of a full academic year includes room and board, books, tuition, as well as everything packaged in. Some people commute, some people can lower that number depending on their situation, and so let's just use tuition for in-state individuals. So let's just use in-state tuition. And so that is tuition underscore in. Tuition fee underscore in. We're going to take the mean. And then the next, we're going to do the same thing, but the median for the in-state tuition. Same thing. Underscore out. Oh no, sorry, in. We're still doing in. We're still doing in. We're just doing the median. Let's see what those look like. Oh, sorry, we haven't actually put them up yet. We're just calculating it. Mean underscore expenditure. Now this is again expenditure per full-time equivalent. We're doing filtered underscore DF. Dot median. We're taking the median of this value. Now let's display these metrics as cards. And so let's put cards for metrics. And we're going to have 3 columns to display these cards. We're going to have 3 columns just like that. Now with column 1, let's scroll down a little bit, scroll up a little bit. st.metric, mean tuition, and then our value is going to be mean cost. With column 2, st.metric, we're going to have median tuition with our metric, median cost. With column 3, we have st.metric, and we have student expenditure. With our actual variable. Is it we take the mean or the median? We took the median. Median expenditure. Perfect. Let's see what this looks like. There we go. Now we do have to round it. So for mean cost, we just round it right here. We'll round it up here. Let's save it, see what it looks like. There we go. Let's have apples to apples, and let's round it so there's none at all. There we go. Perfect. Next, we're going to actually have a figure. We're going to have a histogram. We're going to have a histogram that shows the actual distribution of that tuition. And for this, I'm going to copy and paste just because there's a lot of going on, but we're going to do fine. So the first thing we're going to do is the actual histogram. So again, we're using Plotly Expressed. We're using Plotly Express. For the X, we're having the in-state tuition. The number of bins, 20. The title is going to be distribution of in-state tuition. The labels, we're going to change this, because this isn't very user-friendly, to in-state tuition, and change the count to number of schools. And our template is going to be Plotly white. Let's see what that looks like. Oh, we have to actually show the figure. And we pass in that figure object. Let's see what that looks like. All right, that's our histogram. And we can actually see how many in-state have a tuition between $0 and $5,000. 0 and 5,000 to 9,000, and then we could go all the way up to 65,000. Now what we also can do is actually display the data. And what we're gonna do that is right up here. We're gonna display the actual data frame. So we actually know where is where. And so we have all this information. We have the locale, we have everything. We have the institution name, the unit ID, and we have the tuition right here. So if we sort, we see 77,000, that goes to La Sierra University. In-state tuition, the highest, 62,000, goes to University of San Francisco. Seems about right. Okay, going on. Now we're going to have the user be able to input an actual budget that they want to have for their region. They want to be able to have a budget. What is on my budget? What schools fall within my budget that I can possibly go to? And so to do that, we have to actually get their budget. So budget equals sc.sidebar dot number input your budget. And now we're going to have them give them suggestions based on that budget. Let's scroll up. So we're going to have a suggested schools variable. We're going to have that filtered data frame, and we're going to filter it based on that budget. Tuition fee underscore in. And we have it less than or equal to the budget. That's how we're going to filter the data. The next thing we're going to do, if not suggested schools.empty. So if suggested schools is not empty, we have this subheader, suggested schools based on budget. And then we're going to have, we're actually going to display the data frame. But we're only going to display the institution name, the zip code, and then the actual in-state tuition. So the first thing we're going to do is institution name. The next thing is going to be the zip. And then the in-state tuition. Perfect. And then else, if that is not the case, we're going to have no schools found within the budget. All right, let's see. So we have our slider here. We can select our state. Let's select another state. Select Indiana. Okay, we have our actual numbers. And that's been put in our budget. So I can afford 18,000. That is my budget. What schools can I afford that are 18,000? I go scroll down, I see the distribution. Schools based on my budget. And let's sort it. I can go to Holy Cross College, I can go to Purdue, Bethel University, Hanover College. Okay, now I have some options, and I have the zip code in case I want to get more information on these universities. Let's make this look a little bit better. It's bugging me that use container width equals true. There we go. That makes it better. Makes it a lot better. Thanks for tuning into this video. I hope you enjoyed it and I hope you learned something. During this video, we went over a couple imputation techniques. We worked with a novel data set that I don't think many people have worked with before. And then we created a dashboard with Streamlit to allow a user to query this information. If you want to see anything else, if you want to see some features added to it, if you want to add some features to it to yourself, you can clone the repo, edit it however you see fit. If you want to try another imputation method, let me know, tag me in it. Comment down below. What did you think? Did you want to see anything else? Do you think I could have done the imputation a little bit differently? Do you think I should add anything to the Streamlit actual dashboard? Let me know in the comments below. Like, comment, subscribe, and I'll see you in the next video.